So next part is the file structure and file directory permission, right? So during the terminal class, we talked about the Linux file system, where each directory stores what kind of files, right? So most Linux distributions share a common file structure. So as a result, no matter which distribution you're using, you should be able to navigate around and use the same kind of commands. Now, however, not every user or single operating system should have the same level of access to files or directories, right? Like any professional or enterprise level operating system, Linux has methods for securing files and directory access. So this security system allows the system administrator or the file owner to protect their files from unwanted access or tampering by granting select users permissions to read, write, or execute. So for each file and directory, we can specify the permission status for the file's owner, right? For particular groups or even just regular users. So this is a necessity in a multi-user enterprise level operating system, right? Because in most of the times, if you have a single machine that is running, let's say a file server, you might have 10 admin users who might be remoting into it simultaneously. So each of them should have different access to different folders and directories. Now, you've learned about this in Windows, and the way we do it is using Active Directory, right? Using the OUs, the organizational units. Using that, we can set up different groups, and different groups can have access to different kind of different files and different assets and resources. Now in Linux, it's a bit different. You can connect to a Active Directory session, but it also has its built-in system. So we'll take a look at that one. It's quite interesting. So each and every file directory must be allocated a particular level of permission for different identities using it. So there's 3 levels of permission, which is read, write, and execute, denoted by R, W, and X. Right. So R stands for read, W for write, X for execute. So the root user can grant users a level of permission depending on what they need the files for. So when a file is created, typically the user who created it is the owner of the file, and the owning group is the user's current group. So the owner of the file can grant various levels of privileges to that file. Now, the other person who can also grant this kind of permission is the root user, which is like the super administrator, if you will, right? So there's only 2 types of people who can do it. One is the owner of that file or the directory. The other one is the administrator, which is the sudo or our root. So if you want to check the permissions, it's actually quite easy. You can use the ls-l tool or option to take a look at the different permissions that each of these files have. So we can see over here, the first one from left to right, we can see that the first letter is what tells you whether it's a directory or a file. So a directory will be denoted by D, a file will be a little hash sign. Second over here is actually the permission. So you can see it's a bit daunting. But at the end of the day, if you just come back here and see RWX, you can see it's just RWX, RWX, and RWX, right? Number 3, we don't really care about it. We're not going to talk about it. It's basically hard strings. We won't get into it too much. But if you look at number 4, this basically tells you who is the owner, right? Number 4 is the owner, the user, and the one beside it is the group. So in this case, the user is root and the group is also root. Number 5 is the size of the file or directory. In this case, you can see the directory over here is pretty big, but the other ones are 4096 kilobytes. Number 6 is the date that was last modified, and number 7 is the file name or the directory name. So you can see over here, these are directories without a dot, without a extension, and these two are files. Any questions so far? All right. So next, let's take a look at how we can grant permissions. So how can we assign a permission to a file or a directory? Well, first of all, there's two ways to assign a permission. One of them is using the RWX to set the permission. The other way is using the numeric method. So this method is based on the binary representation. So no permission is indicated by 0. So if you can see over here on the left-hand side is the binary. The middle one is the octo, is the number. And on the right-hand side is the permission itself. So no permissions is represented by 0. Execute permission is represented by 1, right? So you see over here it has 3 digits, I guess. And then you have 3 binary digits over here. So 1 and 0, it's nothing. And then on binary, when you go up by 1, you start from the right and you go up by 1, right? So when you have X, you go up by 1. If you have right, you go up by another 1, which makes it 1, 0. And the binary number is 2. You go up by another 1, binary number is 3. It's represented by 0, 1, 1, and the actual permission is write and execute. You go up by another 1, so number 3 is represented by 1, so 1, 0, 0. 1, 0, 0 equals to 4. So binary of 1, 0, 0 is the number 4, which is read, right? And then it just keeps on going. So 1, 0, 1 is read and execute. 1, 1, 0, read and write, and 1, 1, 1 is read, write, and execute, right? Another thing you might want to know is that if you want to add them together, right, you might see that it's quite interesting. So if you add 1 and 2 together, which is execute and write, you get 3, right? 1 plus 2 equals to 3. You get write and execute. If you want to add write, execute, and read, you plus 4 and 3, and you get 7, which is read, write, and execute. Now, even if you want to plus 6 and 1 together, because RW is missing an X, you plus these together, you get 7, and you get the read, write, and execute. So this is how you kind of figure out what permissions is represented by what number. And it's actually quite easy if you once you get the hang of it. Any questions on this one so far? Everybody got it?
Yes.
Okay. So let's take a look at an example over here. So first, if you want to set only the read permission, we could use the permission table on the right over here to see what we want to give. So if it's just to read, we're going to assign it number 4. So next, if you want to set the permission to write and execute, we can use the same methodology. Write and execute 2 and 1, we're going to get 3, right? So let's open up our terminal over here. So this is the remote session, and then let's try to take a look at it. So let's cd into downloads. Let's just create a new directory called permissions. So let us create a file really fast. So echo, this is a permissions test. Oops, I need to save it as permission.txt. Now, if I want to take a look at what permissions I have right now, I'm going to use ls-l and then permissions.txt to see that what values, well, what permission I have right now. So if I just zoom it up a little bit, you can see that we know it is a file because it has a little hash at the start. We know we have read, write, and nothing, read, write, and nothing, and read, write, and nothing, right? We know that the owner is called Callie, the group is called Callie, the size is 27. The last time it was accessed was just a minute ago, and then it's called permissions.txt, right? So let's say we want to change the permissions. We're going to use a command called chmod, so change mod. And then we're going to just write we're going to use one of these numbers. So 4, and then we're going to type in the permissions.txt, right? So with that being said, can somebody tell me what might be the result of this? Before I press on enter, can somebody tell me what is the expected result?
It should be, it's going to be, it should be read.
Sorry, say that again. I didn't hear you, sorry.
It's going to have just the read permission. No
It's only
write
going to
permission.
have the read function. So let's take a look. LSW and then permissions.txt. You are correct. It's only going to have the read function. Now, here's something interesting, right? We only have read function for the other users. So if you're reading it from left to right over here, wait, hold on, where's my picture? Okay, so the first group over here represents the owner. The second group over here represents the group. The third one over here represents other users, right? Let me just get back to this really fast before I move on. Paint. So first of all, we have the directory, right? And then we have RWX, RWX, and then RWX, right? So we have 9 in total. The first RWX represents the owner or user, right? This is a bracket. The second one represents the group. And the third one represents other. So this could be other users, other devices, anything that is other, right? So that's how you read it. From owner, group, and other. It's always going to be in this direction. So now if I look back into over here, why is it that only the others portion has been changed to read? Why not group, and why not the owner? And can you try to give me a guess on why that happened?
Well, I think it should be because of the presentation.
Because of the presentation, right? Because I only have a single 4. Now, if I want to change 403, shouldn't I have 3 numbers in total, right? So let's give it a try. So what if I added 4, 4? What do you think will happen?
And the group and other users is going to have the read permission.
Exactly. Let's take a look. Yep, we have now the group and the others. So now if I add 444, what do you think is going to happen? All three of them, right?
All three of them, yeah. But
Okay.
I have a question though.
Yep.
So is it that, so if you just have one number, like the four, for instance,
Okay.
based on the chart, that's how you know it'll be other, correct?
Yeah. So if you only have one number, it's actually going to start from the right. If you have
Okay.
two numbers, you're gonna have two. Yeah, if you have three numbers, then it's just three. It's not gonna change.
Okay.
So the best practice is always to put three numbers, even though it might be repetitive. You should always put three just so you are absolutely sure. So now let's try to give different kinds of permissions based on what we know, right? So if I take a look at the chart over here, let's say I want to give the owner read write access. So let's say I want to give the owner. So we have owner group and then others, right? So let's say owner is going to be read and then write, group is going to be execute only, and then other is going to be write and read and write and execute, right? So what should the number be? It's going to be change MOD. What is the number? Can somebody tell me?
It's gonna be 613.
613. Let's try it out. 613. Then LSL permissions.txt read write. We got execute, and then we got write and execute. Right, perfect. So seems like you all got the hang of it. Any questions before we move on?
This is fun. This is probably the best thing I'm learning right here.
Awesome, awesome.
Telling you.
This is gonna be really, really useful later on, especially when you're hacking. I'll talk about some methodologies, and then during the actual penetration testing course, I'll go through on how you can actually exploit this, right? Because this is really really fun.
Yeah.
All right, so this is one method of changing your permissions. So without well, first of all, let's actually try it out, right? So let's do change mod. Let's change it to 000. Oops, I have my insert key on. Right, so if I do LSL, I should see there's nothing, right? So if I try to cat permissions.txt, I'm gonna see permissions denied. Right, so now again, if I change it back to 777, and then I try to cat, now, hold on. Read, write, execute, read, write, execute. If I try to cat permissions.txt, this is a permission test. Okay, so that works. All right, so that's just confirming it actually does what it's telling us to do, right? So let's move on. This is only one of the ways we're changing this. There's another way to change it, and that is using the UGO syntax. So what is UGO? UGO stands for the user group and others, literally U, G, and O. So the way we use this is through the syntax of a minus sign, a plus sign, and a equal sign, right? Think of it as addition. This is literally addition. So minus removes a permission, add will add a permission, and then equal sign will set a permission, right? So let's do a quick demonstration over here. So let's clear the screen. And then ls-l permissions. Quickly, we're just going to take a look at what we have right now. So we have RWX, RWX, RWX. So let's try to remove all permissions. So chmod minus RWX and then permissions. Sorry. Rewrite, execute. Oh, wait. Where's my permissions right now? It should be remove all permissions. So minus read, write, and execute. New permissions are write and write, not that. I am not sure why it's not deleting all of them. But okay, so right now we have write and write. So if I want to remove these two, right? If I want to remove these two, I should be using minus write. I guess it's not letting me to remove all the permissions. So let's add another permission. So chmod, if I want to add a permission, so for example, add x and then permissions.txt, right? -l, what do you think is going to happen? Is it going to change to all of them or just one of them, or what's going to happen? Somebody tell me.
They're gonna add execute.
It's going to add execute to which one? Which group?
They're gonna add execute to
Just take a guess. It's not going to be wrong or anything.
They're gonna add execute to, we're gonna say, to the
User group.
Yeah.
Where's the group? Oh, let's test it out, right? We add it to every one of them, right?
Okay.
Execute to all three groups.
But why? Yep. Why?
Yeah, because this type of syntax will add X to all three of them. It's like the simple way of doing it to it universally, right? Whereas when we were doing it using numeric method, we had to specify each one of them. In this case, if we're just plus X, we literally just add it to all three of them. So this is not a very recommended way of doing it because especially in a enterprise environment, if you do something like this, any other users that have access to that machine will be able to execute whatever you just typed in, right? So it's not the recommended way of doing it. But if it's just you by yourself on your own machine, then feel free just to use plus X. Like even when I download a script from the internet, I need to run it, I would just use plus X instead of doing 700, right? It's just like a quick and easy way. Now, but like I said, this is similar to adding and removing with addition and subtraction, right? So let me try something different that is really cool. So I'm gonna clear this really fast. I'm gonna do plus read, write, and execute. Right, so if I do ls L permissions, I can see I have every one of them, right? So now I'm gonna just remove one of them from a different one. So chmod users minus group and then permissions.txt, right? Now, what do you think happened? What do you think is going to be the result?
Will it just be the others that will show?
Okay, so hold on. So if I have, I have a what do I have? I have users minus group. So this is the users, this is the group, and this is the others. So initially I had RWX, RWX, RWX. So I did U minus G, right? So now I did U minus G. What do you think is going to happen?
It will just be, I mean, it'll cancel. I mean, it'll cancel out basically, no?
Which will cancel out?
So
I think it cancels out the group.
the
It
group,
cancels
right?
out the group?
I
Because
think
it minus G, right?
both. I thought both, since they're the same, both the owner and the group should just equal 0. No.
So it will be hash, 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 and then
Yeah.
RWX.
Yeah.
Yes.
Is that how math works? So let's say we have we have A minus B equals to, so if I have 4 and this is 2, right? It should be 0.
No, it should be 2.
No, that's the
It should be 2, right? So why? Okay, I guess it's not a great example. So let me just show you. So I canceled out the entire owners group, right?
Okay.
Why did it happen?
Yes.
Why did it happen? So let's look at it visually, right? We have RWX and then we have RWX. So U minus G, isn't that just RWX minus RWX, but we're applying it to the users group, right? We're basically saying that users should minus whatever is in G, but G doesn't really change, right? We're just minusing, we're just subtracting from the users. So if I do users minus G, G has RWX. That means that users RWX minus RWX, which gives me nothing, or in this case, the 3 dashes. Does that make sense?
Yeah, I mean, but yeah, that's technically what we were saying to a degree, right? Because when we said 0, 0 equates to the 3 dashes, no?
Oh, I see. I thought you guys meant that it's going to be dash, 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 and dash, dash, dash for the G as well. No worries. As long as you understand, that's perfectly fine.
No, it's okay. Yeah, it's okay.
So let's do another one. So I'm just going to add that back in. So quickly, chmod, I'm going to do G minus R to permissions.txt. So what do you think is going to happen?
So it's gonna be RWX dash 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 RWX.
Hold on. So it's going to be RWX dash 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 RWX.
I think so.
Is that the final answer that everybody agrees on?
Team, what do you guys think?
We should have from the which group now? From the group,
Okay.
we should only have the write and execute function.
Okay, so we got a different
Dash dash
answer.
dash.
So we should have the write and execute, but you said that the R is gone?
Then the honors should be dash dash dash.
Sorry, the entire thing should be dash dash dash?
No. The group will have write and execute.
Write and write and then execute. Read is dash, and the other ones are, what is the other ones?
The other ones remain the same.
Remain the same. RWX, right? Well, in this case, the same is actually dash dash dash. So I'm gonna just delete that one really fast. So dash dash dash. So we got 2 answers. This one and then this one. Which one do you think is gonna be correct?
I'm gonna go with my answers too.
This one? Okay, let's take a look. So if I do that, we can see. Just as you said, R is gone. Everything else is the same.
Good job, good
Right?
job.
Why did it happen? Because right now we said group minus R, right? So we're subtracting the read permission from group. right? Like always think of this as addition and subtraction. You're always either adding it or subtracting it, right? We're
Okay.
not setting it as a absolute value, which actually brings us to our next demo.
Hold on, before we go to the next one, just
Okay.
so that I understand. So from group minus R, right? Is basically you're gonna from that group, you're gonna take away the R and then of course dash 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 the owner, basically.
Yeah, so the owner's dash 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 is from the previous one. So u minus g was from the previous one. So this is
Yeah,
continuous, right?
okay. That's where I messed up. Okay.
Yeah, so this is a continuous kind of thing. It's not like the numbers. Remember when we were doing numbers? This is
Yeah,
setting it as an absolute value. So no
okay,
matter what number we set, it's always going to change. Whereas over here, it's always continuous because we're just adding and subtracting and adding more and subtracting more, right?
So for instance, if it was G minus U, it'll basically um
G minus u.
yeah, let me put my head down.
So what is G minus U? So first of all, let's take a look over here. So we have group minus, so if I do G minus U, right? Let's try it. G minus U permissions.txt. What do you think is going to happen?
It's not gonna work.
Well, nothing happened. Why?
Yeah. Because there's no the user is already
There's nothing, right? There's
nothing
nothing
there
to
yet.
subtract. It's like 4 minus 0. It's still
0.
4.
Or
Right? Exactly. So, however, if I do this one minus, so it's gonna be O minus G. What do you
okay.
think is gonna happen?
So if we do O minus G, are we then gonna move the it'll be hash 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 dash 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 RWX?
Yeah, probably. So if I do that, it's gonna be
No.
RW.
Okay,
Well,
so
right, execute and read. So hold on. Others minus G. Yep, that is exactly it. Right, because this one is others. Others is the last three one. Minus G is WX. So the last one subtracted W and X, which resulted in WXR. So WX is for the group, read is for others.
okay, no, makes sense, makes sense.
Make sense? Awesome. All right, I think that is for the, oh yeah, you can also use a comma to do additional things. So let's just add everything back together. So chmod plus read write execute, right? We can do u minus o, and then let's say o minus x. And then you cannot put a space in the middle. And then you do permissions.txt. So what do you think will show up this time? So right now we have everything. Actually, we don't have everything. We have one missing, right? So I did u minus o and o minus x. What do you think is going to be the outcome over here? RWX, RWX, R space X. So this is UOG, right? So U minus O. So RWX subtract RWX. This is gonna give me hash hash hash. And then O minus X. So O minus X subtract is gonna be RW hash. And then G doesn't have anything. So it's gonna just be RX. Would that be? Oh, wait, I did something wrong over here. What did I do wrong? Anybody want to correct me? Christian?
Yeah, I'm here.
So what did I do wrong over here in the little paint box?
You remove the read and write.
Nope, it's the order, right? It's not UOG. It's, what is it? It's UGO, right? So I need to subtract something different. So it's UG and then O. So what is this? It's U minus O. So in this case, everything needs to change. Okay, so U minus O, so R X, if I do subtract, it's gonna be nothing, right, nothing. And then it's gonna be G doesn't change, so it's gonna be RWX. And then we have O, which is O minus X, so it's gonna be R hash hash. Right, so that's probably gonna be the outcome. And then if I compare it, you can see it's W, RWX, and then R hash hash, just like I drew over here. All right, so this is one way to do it. We used addition, we used subtraction, and then we can use the set permission. So this one is also really easy. So we basically say change mod. Instead of adding and subtracting, oops, somebody is echoing. Okay. So instead of using add and subtract, we can actually use the equal sign. So U equals to RW, G equals to, let's say R, and then O equals to W. If I do that, and then the LS permissions, you can see U equals to RW, G equals to R, and then O equals to just W. Right, this is probably the easiest way to do it. You're never going to mess this one up, but this is also going to be really long to type, right? So that's just that, just keep in mind of that one. But this is basically how you grant permissions to files and folders.